Okay. So welcome to YEAH Hours.
Shit.
My water bottles.
Yeah.
Okay, so this assignment is actually like pretty intense. It's probably the most intense assignment of the whole quarter. So we want to do a little bit of a session where we kind of go through the assignment piece by piece to kind of give you a little bit of insight into what you're going to be accomplishing over the next week. So what we're going to do is we're going to talk about a couple general topics on strings and stuff like that. And what's the other general topic? What's your thing?
Mostly the printf parts of the assignment. So the assignment's in two parts. There's like a strings module and a printf module. So I'll be talking mostly about the printf module. So
yeah, so we're going to do strings. We're going to do printf. We're going to talk a little bit about testing. We're basically just going to go through the whole assignment and explain it. And this is also a great opportunity for everyone to ask questions. So if you have a question, feel free to raise your hand. That's why we're here. So to start off with, are there any questions that you can say?
So there's in like the files that we have, is there no like strings.h file? It's only like the GitHub like.
Okay, so the question for the recording was there's no strings.h. I think that's a mistake. I think we'll fix it right after this. Yeah, because that's pretty crucial in terms of documentation.
There's like a link on the assignment page. It says like strings.h. You click on it, takes you to like GitHub and like has the strings.h, but it's not.
Okay, yeah, it's not on the starter. Okay, fix that. Yeah.
Will there be a tag in the discussion about, I guess, certain aspects of GDB simulation that would be useful for this assignment outside of kind of what we learned in lab? I mean, in lab we have like step and functions and next and general type thing, but there's like certain caveats I'm bringing to the GDB sim.
So I'll be talking a little bit about GDB and how to best use it to your advantage for this assignment, kind of toward the end of YEAH Hour, or like at the end of our kind of presentation. Just talk about what you'd want to use that's different from what you did in lab, and also just like general strategies for testing and debugging. So yeah.
Okay, awesome. Any other questions? Okay, great. So let's do a really quick review of C strings. We learned about them in lecture on Monday, I believe. Does anyone remember what they are? What are C strings? What do they look like?
And shout it out.
Yeah, it's a character array, right? So in memory, it's just going to look like quality marker.
Do you want to use this one?
I'll stick with this one for now. Oh, is that visible? It's kind of not visible. You're really going to have a lot of fun watching this later. Okay. Okay, so it's a character array, right? So you have hello, H-E-L-L-O. Each of these characters is going to be 8 bits or 1 byte. Right, so that's probably that's the smallest unit. What?
This is not a C string.
No, wait, I'm getting this. Okay, so if I told you, given this diagram, give me the length of the string, and it's pretty easy to see that's 5, but how would you do it, like programmatically? Bless you. Yeah, exactly. So we can go through it. We can say, okay, there's an H, and an E, then an L, then an L, then an O. But there's really no way right now for us to tell when we should stop doing that counting. So you're totally right. We need one additional thing to make it a C string, as Jane suggested, which is a noun, \0. Right? That's going to be that's like a null character. Its literal value is 0. Null, and it's called a null terminator. So that's going to become your friend. That's what's going to tell you that you've gone through the entire string. So there are a lot of functions in the assignment that you have to implement where you're going to be looking for that exact value so that you know when to stop processing. Right? Make sense? Okay. And so this is fine. And if I said this is a car stir, and I want to change the second character of it, what would I do? How would you change the second character? Yeah.
You say like stir 1 equals.
Exactly. So when it's an array of characters, you can just index it and then change the values, so Z or something like that. Right? Okay, great. But what if you want to copy it to somewhere else? How do you do that? Say it one time. If I want to copy the string, I don't want to change it. I want like an actual copy. What do I do?
You have to go like 1 by 1. Like
Yeah, so you go one by one, but the critical part of copying a string is that you need somewhere to put it, right? So all these strings are taking up memory. That's kind of the way that you can think about it, is that they're just kind of little chunks of memory that you're throwing around. So to copy a string, you need an equally sized piece of memory. It's going to be down here. And then you can copy every character into it. H, E, L, L, O, and the null terminator. Oh, it's not a theta, it's a 0. Okay, yes?
So, are you saying, when you said it has to be equal size, are you saying that it wouldn't work if there was additional indices?
Yeah, so the question is, would it work if it was bigger? It's a great question. So if I had an array that was, instead of it being 6 characters long, so instead of it being a character array of 6, I'd say a character array of 8, like this, then it would totally work. Right? So this is what we would call a buffer. Right? It's something that you're going to take characters and you just want to move them somewhere. You're going to move them into this empty character array called a buffer, and it just has to be as long as the thing that you want to copy. Yeah.
Would that eventually cause like a memory leak?
Not necessarily, because you still have a reference to it. So
but is it still like accessible, like past the null?
Yeah. Oh yeah. So if we said this is like stir2 of 8 is equal to that, then I could say stir2 7 is equal to C. That would totally work. So as long as you have a reference to that memory, and we're not dealing with, like in 1.6b we had heap allocation and everything, so you could lose memory and stuff like that. Here it's all in the stack, so you're never actually going to lose any memory. Yeah, any questions about that? So in the assignment, when it talks about you want to move things into a buffer, you want to allocate a buffer, what's really saying is you want an empty spot somewhere you want an empty array, you want to put that somewhere in your program that you can use to copy values into, to copy string values into. Okay, what happens if for example, you're running stir copy, which is the string copy, you have a buffer that's too small? What could happen?
Like override other information.
Yeah, you could override other information. So if you had like one character array that was like this big, and you had another string that was like right next to it in memory that had your like the last 4 digits of your social security number, and you rewrote hello over it, suddenly you don't have a social security number anymore. So you should probably be pretty careful. Okay, that was a great question, or slash answer. Okay. Okay, so we have all these buffers, and so the second part of C strings is that not only do we want, yeah.
Good question. So if we're trying to write hello in something that only, I guess, has 4 spaces, you say it'll overwrite to like this next slot that we have, like another memory slot, or is that in a situation we have like 2, 4?
No, this is the next memory location. Yeah, so the strings are just in memory, so if you just write to the next like memory location, you could write over a string, you could write over like nothing, you could write over your stack pointers and stuff. That stuff could happen.
If you were to add the C at index 7, and that's after the null terminator, what happens? Does it move the null terminator?
Just lets you do it. Yeah. So if you said stir2 7 equals C, then it would just put it right here. That's it. Yeah. So the language C is really nice because it'll let you do anything you want, but it'll also let you do anything you want, which is bad. Okay, great. So we have buffers, or we have strings, we have buffers. Now how do we share strings? Like, say I don't want to copy my string every time I give it to a function. What would I do instead? Yeah, you get a pointer, right? So that's going to take, pointer to a C string is going to be a character pointer. And so you're pointing to the start of a character array, and the way you can think about this is if I have some string, my pointer is pointing to the first character in the string. And so that's why it's a character pointer. And you can send them along to any function, and you can modify them, stuff like that. But the thing that you should probably remember is that when you're dealing with strings, even if you just have a pointer, the memory has to be somewhere. And so you're always dealing with a certain memory location. So if I said, so if I had this car stir array equals hello with null termination, and I just wrote that in main, where is that stored? It's stored on the stack in main. And so when you're modifying the string, you're modifying the variable in the stack frame in main. But if you write something like, and this is like the last thing that we'll say about this, but if you write something like printf and then hi, this is a bad example, my function and hi, then what happens is that where is this string stored? You didn't store it in a variable. And so what the compiler is going to do is it's going to store it in the special read-only memory, read-only section of memory, right? That's compiled with your program. And if you decompile it, you'll see like all your instructions, and you'll see a segment where it's like hi. It'll just say the string hi. And so it's just stored with your program. So if you try to modify that inside of my function, it'll crash, and it'll be happy. Okay. So probably wasn't super useful, but just remember that they're always stored in memory somewhere, and so you gotta be careful about what you're modifying. Okay, and the last thing is that you can have you notice how we have these two types, this character star and this character array, right? What's the difference between them? Like, kind of seems like we just use them both. Does anyone know? Yeah.
Oh, sorry. When you're saying hi with the function, are you saying if you modify, like, hello, or?
I feel like I opened a can of worms I shouldn't have. Okay. So if you do something like that, actually this is a good example to run through. So normally what this does is it says, okay, find the memory location pointed to by A, which is where the string hi is stored, and then go to the first character, which is I, and change that first character's value in memory from an I to an F. Does that make sense to everyone? Okay. And that's where it's really important to recognize where this A comes from in this function call. Because when you say go to the memory location of A, you didn't allocate A in your main stack frame. So you're not modifying the stack. What you're saying is go somewhere where this is saved, often we'll call this read-only land. Wherever that is. Right? So you're going over to read-only land and you're trying to write in read-only land. Right? And because of the rules, because we said it's read-only, you can't do that and your program will crash. Right?
But isn't it a pointer?
Yeah, it's a pointer to somewhere. Well, actually, oh man, I really stepped in. So it is a pointer. It's normally a pointer to read-only land, right? So you can't. So even though you literally know where it is, you can't change it. Now, unfortunately, the Raspberry Pi doesn't have an operating system to tell you that you shouldn't write in read-only, and so it's going to let you do it anyway. Right? This is just an illustration that you should probably pay attention to where these strings are coming from.
Wait,
okay.
Sorry, are you saying that you can't change it to HF through that, or that you can?
Normally you can't, but on a Raspberry Pi you can.
Only on a Raspberry Pi.
Without the operating system you can.
So we can do that, but it's
But
not.
don't do that.
Don't do
Don't do that. Okay.
But we should have initially declared it as star.
Yeah. So okay. So I guess that's the right takeaway here. Is that if you want to be modifying a variable, you should have declared the variable already in the frame. So instead of doing this thing, you should have done our array, A is equal to hi, and then pass that in like that. Yeah.
If you accidentally write over memory, but then you fix your bug and reinstall it, it shouldn't be an issue.
No, it shouldn't be an issue. It's only when you're running the program. Yeah. Yeah.
So what's the difference between using the A or using the I there?
You're actually declaring the variable in your stack.
So that way it's not written in the read only memory.
Yeah.
So is it declaring it as an array of cars?
Yeah. So So this syntax here says take this string and turn it into a character array of length. So this is going to be a length 3 bytes. Right, one for each character and one in the null term. Okay, great question. Yes.
So when you call string length on that, you would get 2, right? Because
Yeah, because it it's nice to you and it doesn't just it's not gonna add one for the. Yeah. Okay. Yes.
So the difference, I came in late, so like you're trying to show like the difference between like passing reference and value.
No, I'm just trying to build some awareness for where strings are actually allocated. So if this kind of like flew over, then don't worry about it at all. I should probably think about this. Okay, okay. Very last point on strings. You have these character pointers and you have these character arrays. If you try to find the size of a character array, the computer will automatically know how long it is because you declared as say 8 characters or 3 characters or something like that. If you have a pointer, it doesn't know how long the array is, so it won't be able to do that. Right? For everything else, this just turns into a character pointer to the start of the string. Right? It's pretty much the only difference that you need to be aware of. Okay. Any questions?
Well, I guess maybe one thing to add about character arrays and character pointers is that if you have a character pointer C or something, and you access like C plus 1, that's basically the same thing as saying like C index 1. Those do the same thing. So like that refers to the same address. That's just like a useful thing to know.
C2.
So yeah, adding to pointers and indexing from arrays do exactly the same thing.
Okay, awesome. So first part of the assignment is just implementing a bunch of string functions. So you're going to be dealing with, iterating through characters. You're going to be dealing with null terminators. You're going to be dealing with buffers and copying. Yeah.
So like going through those functions that they want us to do, the value that's passed in is a void pointer.
Okay, I was just about to bring that up. Okay, yeah. So there's one last thing which is called a void star, which is here. It's a void. Okay. So that's kind of like C's way of saying, I will take whatever pointer you give me, no matter what the type is. So it could be an int star, it could be a char star, it could be whatever your random data type star is. Right? It's just going to take all of them. Basically, all you should probably be doing with these, so if you had like void star p, if you want just one byte at that point, yeah, you just cast it. So you just say char star p like that. Nope, not like that. Like that. So if you want char star of it, you just cast it. That will give you the first byte in memory. Yeah.
Should you like create a new pointer that's a char star and cast it?
Like that. Does that make sense? Yeah. That's just like the generic kind of interface that they're using. Okay. Perfect. Anyone?
Yeah. So wait, do you guys mind if I erase this? It'll be in the video later, so. Erase this for now. So the next thing we'll be doing is the printf module, and the first thing that you're going to do for that is implement 2 different integer to string conversions. So one of them is unsigned to string, and one of them is signed. Unsigned to base and signed to base, which means that it's given a value, a buffer pointer, a width, and a base, and you have to convert the number into the correct base and print it as a string into the buffer. So I think one way to just kind of figure out how to approach that problem would be to do an example in decimal. So say you have the value, value equals 107. Say you wanted to print this into a string at, I guess it doesn't matter what the address is, but say like you're passed a car pointer. So in order to print this value in decimal into this buffer, like what will you have to do to this number? It's just like a first step. Yeah.
You have to like break it up and find the ASCII value for each one.
Yeah, so you will need to have the ASCII values for each digit. So in order to do that, you're going to have to access one digit at a time. So what would you say is a general strategy for accessing the last digit of a number?
Modulo.
Yep, modulo operator, right? So 107 mod 10 equals 7, right? So now you've gotten the rightmost digit, the least significant digit. So if you want to keep doing this over and over again for a number to convert it into an arbitrary base, what would be like a general strategy for like, I guess the inside of the loop? So once you have the rightmost digit, how would you go about accessing the middle digit?
Divided by 10.
Divided by 10, right? In integer division. So you do that. 107 divided by 10 would give you 10 because it doesn't do remainders. It's basically a shift. So yeah. So you've got this chain of modulo and division to do that. The other thing to talk about with this function though is that it's going to ask you to implement a width, or I guess it's a minimum width. So if you're given width equals, for this number like 4, for instance, you're going to have to do something special at the end. Because after you get you get to 1 eventually, and you print a 1, but then you've only filled up 3 characters, and you've got a minimum width of 4, which means that you have to add zeros to the left side. So that's basically what the extra width parameter means. Yeah, does anyone have a question about what the width does, or how to convert into an arbitrary base?
Could you repeat what you're saying? You have to shift to the left? The width.
For width? Or
yeah, for what?
For width, yeah. So the width is just saying, like, what's the minimum number of characters that this number can occupy? So, like, if you print 107 with width 4, you should print 0107. If you print 107 with width 6, it should be 000107. If you print 107 with width 2, though, then it's just 107. That's the minimum width. You can still occupy more space than that. Yeah?
Is the width excluding the null at the end?
Yes. I believe so. Yeah. The width is like the width as it appears. So it doesn't care about the null terminator.
Why can we still print 107 with 2? Doesn't it exceed minimum?
So this is the difference between the width and the buffer size. The width is just the minimum, so like you can print longer numbers than the width you give it. But if you try to print 107 with a buffer size of 2, you should print actually just the 7 and the null terminator. And if you try to print anything into a buffer with size of 0, you shouldn't even print a null terminator. So yeah, that's the difference. The buffer size is an upper bound on the number of characters you can print, including the null terminator. The width is the minimum number of actual character spaces that you should fill. Yeah. Any questions about width or buffer size?
Wait, why is it a 3? Like, why is it 2 for 107?
To print 107, like just this with the null terminator, or that looks like 10. Null terminator, I don't know. This has width 3 because you can't actually see the null terminator, so there are 3 actual characters in it. But if you say, like, if you call unsigned to base with base 10, value 107, and width 2, you should still print the full number because that's the minimum width. I guess. Does that make sense, or should I explain that differently? Yeah. Okay. So the actually, maybe I should just write out the actual prototype with all the parameters and orders. So yeah, the parameters that you give it are a char star with the buff pointer, an int for the number of characters in the buff. Oh yeah, unsigned int. Unsigned int for value, an int for base, an int for width. So what each of these things is, n is the buffer size. So like, if you're given, n of like 4 or something, you should not print more than 4 characters, including the null terminator. But say you're given like n equals 12 or something, like just something bigger than the width, and like width equals, say that it's 2, and your value is something with width greater than 2, so like val equals like 4, 4, 4, 4, then you should print all 4 of these 4s. But if n were equal to 2, actually, width should always be smaller than n, so that's not a great example. N is 3, and width is 2, then you should print 4, 4, and a null terminator. Does that make sense? Maybe?
So for that third, when it comes to the buffer size, that third value should be our null terminator, so that should be 4, 4, 4, 0, or just 4, 4, 0?
It's 4, 4, 0 because the buffer size is 3, which means that you can't print more than 3 characters, or else you're potentially overwriting other memory. Yeah.
So if it were like the value were 1, 2, 3, 4, would you be printing 1, 2 or 3, 4?
Oh, that's a good point. It should be 3, 4. So if val is 1, 2, 3, 4, and n is 3.
Oh shit.
Wait, what just fell? I believe you're supposed to print the least significant digits.
Bro.
4 and then a terminator. I think that's right. Am I wrong on this? So least significant digits?
Yeah,
So-
it's
Okay, yeah. So if n is 3 and your value is 1, 2, 3, 4, you just print 3, 4, and null terminator. So you print the last, the last n digits, etc. Or the last n minus 1 digits and the null terminator. The other just kind of like careful thing to watch out for is with signed to base. That's going to want you to add a minus sign in the beginning of the number if you're giving it a negative value. That takes up one of your n spaces and also one of your width spaces.
I'm kind of confused about like how you're reading the value. Like, why is that not? If you're coming from the back, why is it not 4, 3,
Like if you're counting from
Well, like, why is it 3, 4? I guess is what I'm asking.
what? Oh, in the case where you can't print the whole number, you should be printing the rightmost digits. So whichever digits appear like furthest to the right.
Oh.
In this case, it's 3, 4, and the null terminator. Yeah.
But I mean, if someone gave you 1,034, then you wouldn't want like 4321. Right? You actually want the number.
Yeah. So with signed numbers, you want to be careful that the signed character takes up a width and also a buffer spot. So if your buffer size is 2, actually wait, that's not a good example, because you'd never be printing just the minus sign. But it's just something to watch out for that if you're printing negative 10, for instance, and width 4, you should be printing negative 0, 10, because that's 4 characters, and the zeros go in front of the most significant digit, but after the negative sign. Does that make sense? Okay, cool. Yeah.
If you're printing, sorry, going back a little bit, if you're printing 1, 2, 3, 4, and n is 4, then how come you don't print 2, 3, 4, and then the null terminator?
If n is 4, you would print 2, 3, 4, and then null terminator.
Oh, you would? Oh.
What if we n is 3 and value is 1, 2, 3, 4, and width is 5 or 6?
And wait, n is 3, value is
1, 2, 3, 4. And the width is 6. We print like the zeros and then the 3, 4 backwards.
so you shouldn't ever have to be passed a width that's greater than n. That's something you should check for. And in that case, you would still only print up to n. So if n was, wait, you said n was 3?
Yeah.
Okay, n is 3, width is 6, value is 1, 2, 3, 4, you would still print 3, 4 in the null terminator. Yeah. Any other questions about this? Okay, so then that's it for the base conversion stuff. The next thing that you're going to be doing is something called Assign3 which is printing a string into a buffer that you pass into the function. So this is very similar to, or it'll have kind of a similar form as like the stir copy stuff that you did in lab, in that you're going to be reading you're reading the format string, and you will be formatting it and then printing it into a buffer, essentially copying into a buffer. What makes this tricky is that you're supposed to be able to account for different types of formats. So the ones that you're responsible for are C, which is an individual character, S, which is a string of characters, X, which is unsigned hex, D, which is signed decimal, and P, which is a pointer. All of these will call your other functions. So like D, for instance, will call signed to base, X will call unsigned to base, but they will all essentially end up doing the same thing, which is print some sequence of characters into a buffer. So if you've decomposed it right, you'll be able to share a lot of the code, because most of what you'll be doing is printing into a buffer. The way that widths are handled with these special characters is that widths go between the % sign and the character specifying the base. So like %04x would mean print like the argument corresponding to the. Oh, I guess I should go over this in a different order. Maybe. But say there's an argument here that has a value. That's saying print this value in hex unsigned with width 4. Are there any questions about how widths are used and how like, formatting characters are used in strings? Yeah.
Can you see like more explicit example of going from
I guess like a formatted version of that to the output that we should see?
Yeah, that's a really good idea. Say that your formatting string is like CS %x, and then your next argument is the value 0x107, right? So you're passing this into SN_printf. There are other arguments too, like the buffer size. I think it's just the buffer and the buffer size, and then the rest of your arguments. But if this is the formatting string, you'll be printing out CS and then this value in hex unsigned, which is 170. However, if this had a width of say 6, then you'd print out CS 00107.
Why do you think a 0 and a 6?
I think that's just convention. I think so. Yeah, I'm pretty sure that's just convention.
So
I'm not really sure what happens if you just do %6x. Probably the same thing. Yeah.
So it's 2 digits. The width.
The width specifier? I'm honestly not sure if it has to be 2. Yeah.
Is it in decimal?
Yes, the width specifier is in decimal. Yeah, so like in your formatting string, you're only going to be passing values that are, or like rather, your program is going to be reading this width specifier as if it were in decimal. Yeah. Mm-hmm.
Sorry, you're saying for the board we just did the X only example. So if it was just X without the width specifier, it's just CS107 without the 0
Yeah, so if you don't put in any width specifier, your program should default to minimum width of 0, which just means print out all the characters. And yeah. Any questions about the width specifier, how to include these formatting things inside the format string? Yeah.
You should look at what each one of those 5 are again.
Yeah, okay, so %C is a single character. So if I had, instead of this, %C.
You could put them all in the same string.
Oh, that's true. Yeah. Well, okay, so say we had %C, and then the first argument was the character 1. That would mean that in this spot, you would print just the character 1 by itself. %S is a string of multiple characters, so we had this with an S, and then the next argument was the string. Well, I guess you'd pass it a pointer, and say that that pointer is. I shouldn't keep using C. str, and then somewhere up here you've got str equals 07, yeah. Then here you'd print out, so far we've got CS107. Remember, this is a pointer, so this str here, like the argument is a pointer. And then x, we've seen, that's unsigned hex. Say that this is 0xe. So then now print e here. D is signed decimal. So if you've got this, we're running out of space. And you've got like -4. So print in -4 here. And then P is a special format for pointers. So that's always going to print out like 0x and then 8 characters representing a pointer. So like a pointer will always have the form 0x, like, I don't know, 2008466AF. Like this is a like all pointers will have the same width. They will all be 0x and then 8 hex numbers. Yeah. So any questions about the formats? Yeah.
Can you go back to the S and like the 07?
Yeah. Okay. So the argument corresponding to %s is going to be a character pointer because it's going to be a pointer to the start of an array of characters that you'll copy into the formatted string when you print the buffer. Yeah.
So the reason there's a %0 and then a number is because we're employing kind of a subset of what you would normally implement, and so this code here just means that you want it to be with 4 and you're going to prepend with zeros, right, which is exactly what you're doing. So that's why the code is there.
So hypothetically, if this were more robust printing and you did like 1-4, you'd prepend with 1s.
Not so sure about
Maybe
that.
not.
I think it's just specially for zeros.
But
That
do we
makes
only
sense.
need to account for the 0?
Yeah. Yeah. So all of your width specifiers are basically saying if your number doesn't fill up the whole width, add zeros in the front until it does.
So if the width were like 14, would it be 0, 1 to 4?
If the width were 14 and the value was what? Or
0, 1, 4.
Yeah, so it'd be 0, 1, 4 like that.
Is that all the questions for SN printf?
So when you're saying the %s one and you put in 0x, does that just returns E, right?
Yeah, that's E. 0x just means that this number is written in hex.
And it returns an x because it's %x.
Mhm.
But you don't put the 0x.
So yeah, I could have passed this as. Oh wait, can I borrow the pen? I could have passed this as 14. If I pass this in as 14, you would still write E here because it's specified as %x.
Okay.
Yeah.
Okay, awesome.
Okay, for SN printf.
Okay, so SN printf is like the hardest part of the assignment. So you should focus on really testing that, making sure that's solid. Once you do, it's time to do printf. And so we run into a little problem. So the first thing that you notice is that this SN printf thing that you wrote and the marker's done.
Mhm. No.
Okay, is it? Oh wow, okay. Does that show up? Okay, I'll just write like super big. Okay, so you wrote this SN printf thing, or you are going to write. And it's going to take like some arguments, so like buffer, args. And it's going to take a format string. The format string is what Jane was talking about with the percent placeholder, so %c, %s, %b, whatever. And then the last thing it's going to take is a ... argument in the function prototype. Yes?
For the format string, if you actually wanted to put a $sign in there, so you know how you add like a backslash,
Yep.
we have to account for that as well in ours. Where if there's a backslash before
I don't think we're doing escape characters, so you probably don't have to worry about that. Oh, what it's going to look like is when you read through the format string, you're going to come across a character that looks like backslash %sign. There's just going to be like one character, maybe. Is that going to be processed that way?
I
No,
don't
it
think we're
actually isn't.
expected to
Okay.
deal with those.
So it's going to look like 2 characters, and so if you're writing an actual printf or SN printf, you would deal with that. Good news is you don't have to deal with that. Yeah, if you want to like work on it for an extension or something, that'd be something cool to look at. Okay, so we have the format string, and you can put any number of placeholders in your format string. So you could have like 100 ints in your format string. You need a way to call SN printf with 100 arguments over here. So C has something called variadic arguments. variable arguments.
Periodic.
Variadic, yeah, whatever the phrase is. Basically, what it means is that you can say, I want my function to be able to accept an unlimited number of arguments. You have so much power. And so you're going to denote that with this ... thing. Right? And it actually turns out that your printf that you're going to write on top of this, printf, is going to basically do the same thing. It's going to take a format string, and it's going to have a ... for the variadic argument list. Does that make sense so far? Okay, so that's where we're going to pull out all of our values. And there's some special, actually we'll talk about the special syntax in a second. And so the issue becomes, you want to call printf, and you really just want to call sn printf, because you already wrote that, and you're not writing it again yet, right? Now the issue is like inside printf, you're like doing some lines of code. At a certain point you get to sn printf, and you're like, oh, it takes a buffer. Great, I have a buffer and a length. And then you're like, okay, it takes a format string. You're like, great, I also have the format string. And then you look at this last thing and you see ... And you're like, okay, how do I translate from like this ... How do I do I just put like ... here? Like very unclear. Like is there like some special syntax? Like, you know, like you get to this point where you're like, I don't know. And the answer is you can't do that. Right, so you're kind of stuck. And so that's why we have to write this kind of like this wrapper thing in the middle. What we're going to do is we're going to write this other thing over here called YEAH. So many letters. Okay, variable list, string, number, or this refers to the size of the buffer, printf. Okay. What this is going to take is it's going to take all of the same arguments as sn printf. So it's going to take like a buffer, it's going to take a length, it's going to take a format string. And the last thing that's going to take is called this. Well, I have to look it up. It's called a VA list. We'll just call it AP. And this is all detailed in the assignment handout. And this VA list type is what you can use to interact with these ... things in these function calls. Right, so we'll talk in a sec how to actually do that. But basically, this boils down to is that you have two functions, sn printf and printf. They both give you ... variadic arguments. I don't even know what to call it at this point. So you want to convert / get a VA list. That's number one. And two, call bsn printf. Right, so you call bsn printf. Same thing here. So instead of this, you call one, get VA list, and two, call bsn printf. Okay. Does that make sense to everyone? So basically our sn printf and our printf are acting as kind of wrappers around this thing, this bsn printf that's going to take a variable list. So, yeah. I'm sorry? Slash get. I'm sorry, it's terrible handwriting. Get. List. Okay. So what does this require? Mainly this requires you moving all of the code that you wrote in sn printf over here to bsn printf. Okay. Questions about that?
What is the VI list actually doing?
Oh yeah, great question. Okay, so let's try to actually figure out how to use this VA list thing. Of course, I didn't leave myself any board space, but okay. So essentially, what you do is inside. Say you're in sn printf. What you're going to do is you're just going to declare one. Just off the bat, and this is also in the assignment handout. So you're going to declare one, and then you call this special function called VA start _start, and you're going to give it AP this VA list. You're going to tell it how many arguments you need, n. Okay? And so you need to know somehow how many arguments are in this ... Can anyone think of a way to do that? Figure it out. Sorry? You could use the debugger, but whenever you run your program, you can't just use the debugger all the time. So how would we figure it out programmatically just using the arguments that we get? The non-periodic ones. Yeah.
Also, what do that still stand for though? Like I feel like that's still not clear to me.
Okay, yeah.
They explicitly are.
So say you call printf. So if I call printf with like social security number %d, right? And then I say 1, 2, 3, 4. So if I call printf like that, what I really want is like SSN : 1, 2, 3, 4. Then this is going to get mapped to the format string, and this is going to get mapped to ... And if I had like two numbers, %d again, that's like wow, %d. That. And then I put another like, I don't know, like 5, 6, like that, and that would also be in ... And so it's basically just taking, so printf is just taking the first argument as the format string, it's taking all the other arguments, and it's just sticking it in this VA list thing. Or sorry, ... Like when you look at the function prototype, it will literally be ... Yes?
What if it were like passed in?
Yeah, so you could pass in how many arguments there were, but that's like not as nice as just it working like magic. But I think you're on the right track. You need to somehow, from the arguments that aren't ... figure out how many arguments there are. Yes? Let's go to the back. Exactly. So if you look at the format string, you see there are 2% Ds. That means I should expect 2 arguments, 2 extra arguments. And so here at VA start, you put a 2 right there. Does that make sense? Okay, great. And so once you do this VA start, can I erase this? Is that okay?
So wait, I don't think VA start. I don't think you actually pass the number of arguments. It looks like you pass the last non-periodic argument. So in this case,
No. So that's the specific thing. Yeah. But that could also. Well, okay. Let's look at that. I'll look at that. Well, actually, if you keep looking at it, if you look at the documentation. Okay, so yeah, so there has to be some argument that tells you how to do that, and then if you have some sort of for loop, this is like a different dot. Let's just put it like that. Then in here you can say it's a VA arg, a function, and you give it the AP, and you give it the type of the next argument. So in this case, or if I had SSN %D %S, %C, then this first one would be an int, right? And then the second iteration of the loop, you change this type to be a character.
What is VAR?
So VA arg is going to pull the next argument from this list of arguments that you have, right? But it doesn't know what type it is, so you're going to have to tell it what type it should pull it off as. If you tell it, get me the next argument, and it's a character, it's going to give you a character back. Right? But if it was an int, then you're probably going to get the wrong value.
So is that just going to be a bunch of if statements, like if D, then VAR, if D, int?
Yeah, pretty much. You're going to be going through each of the, you're going to be iterating through each of the percent signs and turning them into what you want them to be.
Is it something that we're also writing? Is it something that's given in standard arguments?
So you're not going to be writing VA arg, but you're going to be you should have to write the logic to turn stuff.
you will be writing VA.
Hey, what?
In VSN printf, which takes the variable list as an argument, when you encounter %sign, you're going to use VAR to get the next argument. So yeah, you will be using it.
Yeah, you're not going to write it.
No,
But
no.
you have to,
You'll be calling it.
Yeah, you have to implement the logic to say, okay, it's a %d, that means it's an int, so I should pull it out of the argument list as an int.
So you're going through, so we're using that for the two or
That's just a random example. So, whatever your usage is, I'm just saying, like, if you want like all the arguments like right now, then you're going to use a for loop to get to them.
So I guess if I were to, I feel like I got lost somewhere in the step. I was like, something like that, and next thing you know, it's like I see start arguing like 4, like a little bit in between So if I take like we're using VA start and VA art essentially to figure out what was encapsulated in that.
Yeah. So this is here. Let me kind of clean up this board a little bit here. Okay. So let's pretend like you're in printf, right? Okay. And you got this ... list of arguments, and you can't interact with the ... list because there's just no way to interact with it. Right. So there's this library that will do it for you, which is this VA library. And when you say VA start and you give it a structure to keep the arguments in, and you give it the number of arguments, then then it will go and it will get all of the arguments that you pass to the function, and it will collect them in this structure. And then your job is to grab them out of the structure by calling this VA argument.
So VA argument, if VA list is a structure, aren't we just looping through our list?
Okay, so it's a structure, but it's not a list that you can just access and grab variables out of. So
what type of structure is it? Is it just block memory? Or?
I'm not quite sure. It's something special. I don't know. You could probably look at the implementation. That'd be actually kind of cool to look into. But I mean, for the purposes of the assignment, it's just a black box. And the only way you can get things out of it is by calling VAR.
And we know the number of arguments from something else prior to passing, or by counting up the percentage?
Yeah. So unless maybe Jane can correct me, but if I remember correctly, you have this format string, which is, for example, this, and you count the number of placeholders you have, which is the number of values that you expect to follow the format string. So that's what you would use to say, hey, I have like n characters.
So yeah, I don't think that your program will actually go through the format string and count how many format characters you have. Because instead, the VA start, what you pass it is the first argument that isn't part of the variable list. So like when you call Assign3 will call VSN3. But when you use Assign3 to initialize the variable list, you pass it like the last thing before the ... And then the VA list type, or like the library that implements that type, will count how many arguments are in that. And yeah, you shouldn't have to deal with cases. I don't think you have to deal with cases when you're passed more arguments than you should have. Like, you shouldn't ever be passed more arguments than you have format characters for. And if you do, I expect that you just print the first ones and ignore the arguments that don't correspond to them. So, like, for instance, if you're printing a string with, like, oops, that's not hard. Wait, do you have that red marker?
Yes.
If you're printing a string with, like, 3, like, things in it, and the rest of your arguments are, you know, something that's a valid number, something that's a valid character, something that's a valid pointer, but let's just give it a variable, and then like more stuff. I think you're only expected to deal with the first 3. So yeah, you don't actually have to count in the format string. Like VA start will deal with the number of arguments. Yeah.
So VA list is a list of, like, it's the ...
Yeah, VA list contains. So like yeah, when you this will have a name. It'll maybe be called the format because it's the format string. When you do VA start, you give it like the name of the VA list, which you'll probably call AP, and then format, which is the first variable that's not part of this list.
Yeah. So.
Or the last variable that's not part of this list.
So just don't read the variadic functions part of the assignment until we can fix it, because.
Yeah.
Got it. Okay, that's the right way of doing it, though. Yay, Jane.
All right. So wait. So we have like 3 minutes left.
That's basically it for this. Yeah.
I'm confused. So VA start, is it N that you put in or format?
It's the first
for
argument
VA
right before the ...
Yeah.
So are you gonna change the spec then?
Yeah. It's yeah.
Yeah, that'll happen.
Okay. Any other questions on that?
What happens when you have more Are we just supposed to like error check that if there's fewer arguments than there are?
There are fewer arguments than there are function characters. I don't think we're expected to handle that case, or at least from our last year. I don't know if things are different this year, but I'm pretty sure you don't have to handle that case.
Yeah. Oh, and then you call VAN right at the end. Yeah. Because why not? Okay, great.
And that just returns our.
It just does something magic.
Yeah,
You just
not really.
Yeah.
VA list is a mystery.
Okay, Jane, testing. Go.
Testing. Okay, yeah. So, a quick word on just how to make good use of the debugger, because what you did in lab was mostly like instruction level debugging. For this assignment, you will most likely not be working at the instruction level, and so you won't care about step I or disassemble or those kinds of things. I think the useful ones are being able to set and delete breakpoints, which you guys learned in lab. Like you can do break. You can do you can do break. That's not okay. Break Assign3 YEAH, for instance. If you want to set a breakpoint there, you can also actually just type B Assign3 YEAH, and it'll do the same thing. To delete a breakpoint, you just delete or just D, and then the breakpoint number, because you can have multiple breakpoints. So if you've only made this one, D1 would just get rid of it. Continue or C is for if you're running. So if you've already typed run, and it said like breakpoint 1 Assign3 YEAH, and you want it to keep going, then you press C or type continue. Stepping, so like step or S, will step you through the program, and if you get to a function call, it will take you inside that function. If you want to skip over the function call and just go to the next instruction in the function that you're currently in, use next or N. An interesting and useful one, I think this is useful, like more useful for this assignment than disassemble, is where, which will actually print out a stack trace of where you are in the program. So if you've been if you haven't been using step, and so you don't actually know like what the exact path of function calls you've been through is, you just click run, and you hit a breakpoint or an error, you type in where, and that'll print out a stack trace. Yeah.
Wait, what's continue again? What's the difference between continue and step and next?
So continue will run your program until you hit the next breakpoint or an error of some sort. Let's see, what
I want
else?
to talk about zero initialization.
Oh, yeah, okay, so in GDB, it will assume that all of your memory is initialized to 0. On your Raspberry Pi, that's not necessarily true. That's just something to keep in mind. Do you have more to say about that?
Yeah, it's just like if you initialize a variable without setting the value first, then in GDB it'll work fine if you assume that's 0. But if you put it on your Raspberry Pi, it'll start crashing even though it works in GDB because they'll have some other value in it. And if you assume that's 0, then your program will probably mess up and crash. So just be pretty wary of
Or
that.
rather, like, your program won't crash,
Yeah.
but it will behave unpredictably.
Yes. It will not do what you want.
Another thing to note is that once you're doing things with, like, serial communication, don't use GDB for that. Like, once you're dealing with, like, put char and that kind of stuff, where it's actually sending stuff to your Raspberry Pi, GDB will not be able to simulate it anymore. So do a lot of pre-testing of your functions before you start implementing serial communication, because that's the stuff you can actually debug in GDB. And then afterwards, it's just you and your Pi and assert statements. They're your friend. Let's see, what else? This is just kind of a useful thing. You don't have to know how to do this, but you can define sequences of GDB commands. So, like, if you know, for instance, that you're going to, like, frequently be doing step and then print out this variable. Like, you want to do step, print, I don't know, some hex address in, I don't know. You just want to, like, keep track of this address, maybe to see if you're, like, iterating correctly. And you're going to do this over and over again. You can do, like, def sp for step print or something. And then if you type in that, GDB will say, okay, like, type in the sequence of instructions you want. So then you do this and this, as if you're just doing it once. And then you type in, I believe it's just N. And then from then on, every time you type in SP, it'll just do this. So that's convenient if you want to do, like, a loop of more than one instruction over and over again. Yeah.
Is that just every time you open GDB, or does that persist through?
It doesn't persist through like quitting GDB and opening it again, but within one session of GDB you can do this.
There are other ways.
There are other ways?
I
don't know them.
tell you afterwards. Yeah. I don't want to keep everyone while they're supposed to be eating dinner, so. Okay, so that's pretty much all we have.
Thank you.
Yeah, if you have any questions, feel free to stick around. Yeah. Good luck on the assignment. Okay, let me turn this off.